Hello, everyone, and welcome back. Today, we've got an absolutely fascinating explainer lined up for you. Speaking as a fellow researcher who follows this space super closely, we are looking at a miraculous leap. I mean, it's a leap that has caught even the top experts completely off guard. We're going to explore how AI's rapidly evolving mathematical abilities aren't just about, crunching numbers. They are actually the master key to unlocking true artificial general intelligence, or AGI. In just a handful of years, AI has gone from literally struggling with basic arithmetic to assisting field medalists with incredibly complex theories. And it turns out, this evolution in mathematics is the exact map we need to understand the future of all scientific discovery. Okay, let's dive into this. It really starts with a very simple but profound question. Why is math the ultimate test for AI? I mean, when evaluating artificial intelligence, why did researchers obsess over mathematical benchmarks instead of, say, language or creative writing? Well, the answer is that math provides an absolutely flawless, unforgiving testing environment. It is the ultimate yardstick for intelligence. Section 1. The perfect AI benchmark. So, why math? Well, unlike a poem or a philosophical essay, a math problem is totally unambiguous. Everyone agrees on what the question is asking, right? And once an answer is reached, it's easily verifiable. But the absolute most crucial element here is flawless long-chain reasoning. In advanced mathematics, a proof can easily be 50 pages long. It's like a giant puzzle. If an AI makes a single, tiny logical failure on page 2, it completely destroys the entire 50-page argument. It doesn't matter if the other 49 pages are brilliant. This strict zero tolerance for error forces the AI to maintain consistent, rock-solid logic over long periods, making it the perfect proving ground for AI consistency and self-correction. Section 2. From laughable to Olympiad. I want you to think about how fast this is moving. 4 years ago, researchers were practically falling out of their chairs because a model named Minerva could simply draw a line through a few basic coordinate points. In early 2023 and 2024, AI models couldn't even figure out how to split a camping bill evenly among 3 friends or, schedule a simple Zoom call across different time zones. They totally failed at everyday logic. But then, the progress just exploded. By summer 2025, models were achieving gold medal level performance at the International Math Olympiad. They were literally performing on par with the smartest human high schoolers in the world. And mere months after that, they crossed the threshold from solving canned high school problems to cracking completely novel research-level mathematics. Early math models really helped us track these rapid advancements over time, and honestly, the speed of this evolution is almost unbelievable. Let me share a captivating story that perfectly captures this leap, symbolized by the number 42. When researchers like us test these models, we love to use open mysteries. For example, there was this problem in optimization theory involving the Nesterov accelerated gradient method. This exact problem had remained a genuinely open, unsolved mystery in the math world for 42 years. No one could crack it. While acting as a verifier, I dedicated exactly 12 hours over the course of 3 evenings to work with the AI. And I didn't just push a button. I acted as a human supervisor. I was guiding the model, correcting its minor missteps, and pointing it toward novel approaches. In just 12 hours, a human supervisor and an AI successfully resolved a 42-year-old open mathematical mystery. No way, right? But it happened. And that leads us to another incredible number, 1,500. This is the approximate number of papers published by Paul Erdos, who was one of the most prolific mathematicians of the last century. Erdos left behind hundreds of unsolved math problems. Initially, researchers used AI just to perform deep literature searches. The AI impressively scanned thousands of papers and connected completely unrelated fields to find answers to some of these Erdos problems that were basically hiding in plain sight. But here's the kicker. The AI didn't stop at literature searches. Shortly after, the models began inventing completely novel, never-before-seen solutions to more than 10 of these Erdos problems. We're talking solutions so original, they are publishable in top-tier combinatorial journals. Section 3. The Automated Researcher. And this brilliantly illustrates a concept that researchers call AGI time. We've moved from AI models that essentially mimicked a high school student thinking for just a few seconds, to an AI that can think consistently for hours. Right now, we're at the stage where AI can mimic a researcher working for days or even a full week. The context window is expanding so much, allowing the AI to keep track of massive code repositories and huge complex thought processes. The next frontier, the true automated researcher, will be models that can think autonomously, test hypotheses, and verify proofs consistently for weeks or even months at a time, all without breaking their chain of logic. So, what does this all mean for humans? Well, we are shifting away from being the manual problem solver, spending those grueling, isolating hours doing complex calculations and just battling mental fatigue. Instead, we're becoming the human supervisor. Think of it kind of like a professor-student analogy. The human is the seasoned professor who asks the right questions, spots the broad connections, and verifies the work. Meanwhile, the AI is the brilliant, tireless graduate student who actually grinds through the 50 pages of mathematical proofs. The role of human researchers is fundamentally evolving as AI assumes these autonomous, long-chain problem-solving tasks.
Section 4. Expanding to all sciences.
Now, you might be wondering if this is just for math. Absolutely not. The exact same logical reasoning techniques originally developed and benchmarked in math are actually general purpose. Because math is the ultimate test of long-chain reasoning, an AI that masters it inherently masters the logical steps required for other complex fields. Today, these exact same AI reasoning capabilities are being actively deployed to revolutionize wet lab medicine, untangle the sheer complexities of biology, and discover novel formulas in materials science. The idea is spreading like wildfire.
To put that into perspective, the acceleration we are about to witness is staggering. In traditional mathematics and science, a researcher might publish a dense 300-page proof. For the scientific community to manually verify that proof, tear it apart, and finally trust it could take up to 5 full years. And sometimes fatally flawed research is accepted for years before a human catches the error. AI is going to compress that timeline from 5 years down to a single week. It'll instantly connect hyper-niche scientific papers that humans forgot about decades ago and patiently verify massive bodies of work. This is going to dramatically accelerate the speed of human trust and scientific progress.
Section 5. The human in control. So, the crucial point is this. There is a saying going around right now. AI doesn't care about curing diseases, we do. There's a real danger that as AI becomes more powerful, we might just hand over the keys to the castle. If we rely on AI to do all our thinking, we risk mental atrophy. We risk losing the deep, hard-earned expertise required to verify if the AI's complex outputs are actually correct. AI has no intrinsic motivation. It doesn't inherently want to solve cancer or build better infrastructure or explore the stars. It requires highly trained, deeply expert humans to point it in the right direction, ask the brilliant questions, and supply the ultimate purpose. Human expertise is for sure more critical today than it ever was in history. Which leaves us with this final thought. We are entering an era where you don't need to be a human calculator to push the boundaries of human knowledge. You have a tireless, genius-level assistant right at your fingertips. The real barrier is no longer the grueling math, it's the quality of the questions we ask. As the human supervisor in this incredible new era of science, what problem will you guide AI to solve? Thank you so much for joining me for this explainer, and I can't wait to explore our next topic with you.